Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. I hope you all are fine and enjoying good health. Let's continue the topic which is about identification of ions. First, I will solve the questions I gave you in my last video. It says construct the chemical and ionic equations for the reactions between silver nitrate and sodium bromide. It's easy to recall the chemical formula of the compounds and precipitation reactions. First, I will write the chemical equation and then ionic equation. The first one is between silver nitrate and sodium bromide. Formula for silver nitrate is AgNO3. It's soluble. I will write aqueous. Sodium bromide should be soluble. I will write aqueous again for this one. This is an example of precipitation reaction. The partners will be exchanged. The product will be AgBr, silver bromide, and sodium nitrate. We know that sodium nitrate, all nitrates are soluble, so we'll write aqueous. We'll get the precipitates of bromide, so it should be solid, should exist in the solid state. So I will write ions of the compounds which are aqueous. So it will be like this: Ag plus, I'm not writing aqueous here, and O3 minus, Na plus, Br minus. I have to leave this one like this, AgBr. For your convenience, I will write the aqueous for all these. These are aqueous. The ions which are common or spectator ions are cancelled on both sides. Let me show the spectator ions. This is spectator ion. This is also spectator ion. So these will be cancelled. And the final ionic equation will be like this: Ag plus aqueous, Br minus aqueous, AgBr solid. Now I will write the chemical equation and then ionic equation for this reaction. This is a reaction between silver nitrate and sodium iodide. AgNO3 should be aqueous. Sodium iodide NaI aqueous. AgI solid plus sodium nitrate. Now let's make ionic equation. It is easy. First of all, you have to write ions of the compounds which are aqueous. So it will be Ag plus aqueous, NO3 minus aqueous, Na plus aqueous, I minus aqueous, get AgI solid plus Na plus aqueous, NO3 minus aqueous. Now cancel the common or spectator ions on both sides of the equation. These are the spectator ions, nitrate and sodium. So these will be cancelled. And the final ionic equation will be like this: Ag plus aqueous plus I minus aqueous will get AgI solid. The learning outcomes for this lesson are: describe, test to identify the anions, nitrate NO3 minus by reduction with aluminium foil, and aqueous sodium hydroxide, and then testing for ammonia gas. Sulfate SO4 2 minus by acidifying with dilute nitric acid, then adding aqueous barium nitrate. Sulfite SO3 2 minus by reaction with acidified aqueous potassium magnate 7. In this video, I will talk about the test and results for the anions, nitrate, sulfate, and sulfite. For NO3 ion, NO3 minus ion, we will add dilute sodium hydroxide and little aluminum powder. Sample solution. Plus dilute sodium hydroxide plus aluminum. You can even write foil or powder. A pungent smell gas is produced. A pungent smell gas is produced. Which gives the test for ammonia. That is turns moist or damp red litmus paper blue like this. This is moist red litmus paper. And it will turn blue like this. Now, this slide shows the original change in color. You see the color change from pink or red to blue. Pink or red. This one is pink or red, and this will be blue. It's purplish, but we call it blue here. For sulfate ion, add dilute nitric acid and then barium nitrate solution. Sample solution. Plus dilute nitric acid plus barium nitrate solution. Now you have to recall why nitric acid is added here: to destroy any carbonate present. To destroy any carbonate present. White precipitate will be obtained. Here you will get white precipitates. These are of barium sulfate. Barium sulfate. This slide shows the original color of white precipitate obtained for the presence of sulfate ion. White precipitate for barium sulfate. For sulfite ion, warm the sample solution with dilute acid. Sample solution plus warm plus dilute acid. A pungent smell gas is released. A pungent smell gas is released, which turns acidified potassium manganate 7 from purple to colorless. Acidified potassium manganate 7 from purple to colorless. This is a solution of potassium manganate. Potassium manganate. You can write 7 here. It is purple in color. And you see it turns to colorless. This is colorless, indicating the presence of the sulfide ion in the solution. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.